Hello and welcome to the solutions video for our November 18th, 2024 assessments. All right, so with 6 possible learning outcomes, that would be 30 possible marks, so hence all the questions we have here. Now, here we are writing the following numbers in ascending order from least to greatest. So this would be algebra number 2, working with irrational numbers. Our negative numbers come first when we're going least to greatest. So we have to start with 1 and 4 in some order. That eliminates option 3. 1, 5 over 9, that's a proper fraction. So that's between -1 and 0. Whereas the -1.0606 repeating, that would be less than that. It's less than -1. So we have to start for 1. That's enough to get us down to B. Now, had this been written response, we would need to keep going. The square root of 27, well, 25, square root of 25 is 5, square root of 36 is 6. That's between 5 and 6. Number 3, that is less than 1, because the square root of 5 is less than 5. Square root of 5 is between 2 and 3. So 3 has to come before 2. Moving on. A student has successfully factored, and this number is 105,840, when written according to convention. What should appear first? Well, the convention says we do our lowest base first, not the lowest exponent. So that would be 2 to the 4. Then it's 3 cubed, then it's 5 to the 1, then it's 7 squared. If you wish to multiply these together, you will get that 105,840. And this would be algebra number 3, advanced exponents. Now, written response, polynomial operations, we're expanding and simplifying each of the following. So this would be multiplying polynomials, algebra number 4. So our first one here, we just reposition so we can see the question. We have a 9x distributed through the brackets. 9 times 9 is 81. We now have 3 x's minus 81x squared minus 81x. Question 2. This is perfect squares. Do not fall in the x squared minus 9 squared trap. This is x minus 9 times x minus 9, which should give us x squared, 2 terms of minus 9x for a minus 18x. And then -9 times another -9 is a positive 81. In our third one, the 9 distributes to the brackets alone. If we type that at first, not in the equation mode, but just to get this out, we see that we'll have a 16 and an 81 to combine our like terms. So 16 and 81 make 97. So this will be 97 minus 9x. I choose to do the mathematical formatting. You are not required to do so. Now, x plus 9 times x minus 9, this is our difference of perfect squares. We have the product of perfect squares up in part 2. Part 4 is the difference of perfect squares. So this is our x squared minus 81. Hopefully, if you did this, it would come up same way as before. And that, if you made the mistake in the first part, that second one would tip you off. Now, which power is equivalent to the 8th root of t? Again, that's algebra number 3, advanced exponents. We are looking for t to the exponent 1 over 8, because our 8th root is like having an 8th in the denominator of your exponent. Number 4. A computer programmer is looking for an irrational number between 9 and 10. So we're in algebra number 2, irrational numbers. Which number would work in this context? Well, 9 is the square root of 81. 10 is the square root of 100. So we need the radicand, the number inside the radical, to be between 81 and 100. Root 86 is the one that fits this bill. Here we go. Multiple choice number 5. 4 students made the following statements about radicals. We want to find out how many of these students made correct statements. So Adam said the square root of 121 is rational because its value is a whole number. Yes, square root of 121 is 11. Whole numbers are rational, so Adam is correct. Beth said the cube root of negative 8 is rational because its value is an integer. And yes, this is an odd root, so we don't have to worry about the negative sign. In fact, the cube root of negative 8 that we'd be interested in is negative 2. It does turn out that there are actually 3 cube roots to any number, 2 of which involve square roots of negative numbers, but at this point, we are only looking at the negative 2. So Beth would be correct in the context of this course, since the Alberta Program of Studies does not yet acknowledge the square roots of negative numbers. Chris said that the square root of 4 over 9 is rational because its decimal repeats. Yes, the square root of 4 over 9 is actually 2 over 3. Square root of 4 is 2, square root of 9 is 3. 2/3 is rational, and a repeating decimal is one way to say that. Dana said all radicals are rational. Dana is incorrect. So, Adam, Beth, and Chris are the 3 that are correct. We have 3 correct statements about irrational numbers. All right, so now we have to factor 2x squared plus 21xy plus 55y squared. So, A and C have to be 1 and 2, or this is not going to factor. We know that A is smaller than C. So A has to be 1, C has to be 2. There's no other way to do that. Now, B and D have to multiply out to 55. They're either 1 and 55 or 5 and 11. If they were 1 and 55, we'd either be adding 110 and 1 or 2 and 55 when we get our cross term. Because this is not either 111 or 57, we can't factor this as 1 and 55, so we're looking for a way to factor it as 5 and 11. If we do the 2 times 5, right, so if C has to multiply the 5, then B would be 5. That would be 2 times 5 to make 10, leave us with 1 times 11 to make 55. So that would work. This would be A and 5 factoring polynomials. We are back to A and 3 advanced exponents. N to the 1/2 would be the square root of n. So similar to our previous, our multiple choice number 3, except working in the other direction. When factored, x squared minus 1 can be written as, all right, and we see here I'm going to have to tweak the randomizer because we have 2 identical options and I genuinely don't know which it's keyed to. These are random numbers. I have to find out why it is producing the same. In the meantime, I'm going to take a look at the answer key that goes along with this that's generated. It's looking for D and not A. So I will have to dig into that question and find out why it is doing the repeated option so you people don't see that when you write this test next week. That's another reason I pre-record solutions. All right, so which power is equivalent to this? We know that the 7th root puts it in the denominator. This is part of our advanced exponents again. So looking for 148 to the 8 over 7, except we're all in the denominator, so that's a negative. So 7, the 7th root is the denominator of the exponent, and the fact that 148 is the denominator of the fraction means it's negative. Now, we want to find the least common multiple of 15, 25, and 30. Well, 30 is a multiple of 15. It's also the only even number. So if we find a multiple of both 30 and 25, the least common multiple of 30 and 25, should also be the least common multiple of all three. You can also, on the TI calculators, put in 15 and 25, which generates 75, then put in 75 and 30, and see what that generates. This should be 150 either way. The Casio calculators accept a list of three numbers. So you can ask for the 15, 25, and 30 as is. And this would be algebra number 1, working with factors. So now, a company that manufactures doohickeys needs to produce 77 self-sealing stem bolts and 49 framostats in order to make one doohickey. The factory can produce 7 framostats per day. How many self-sealing stem bolts should be produced each day to be ready to make a doohickey at the same time? Well, if it could produce 7 framostats a day, it's going to take 7 days. 49 divided by 7 is 7. 77 divided by 7 is 11. This actually is algebra number 1 working with factors, because that number we were looking at, the 7 framostats per day, the other number is our greatest common factor. That's our connection. We divide each of these numbers by the greatest common factor. That's the number of days. Next, simplifying polynomials, so adding and subtracting like terms. This is back to algebra number 4, which is multiplying or also working with polynomials. So we look at our x cubed y to the 1 terms. We have an 8 minus 5. So we're going to have a positive 3. X cubed y to the 1. We do not combine the exponents in addition and subtraction. So that leaves us with either a or b. Our x cubed y squared, we have a negative 9 and a positive 3. That's a negative 6. Number 7. A number which is both a perfect square and a perfect cube can be factored in this form. Which statements must be true? So this is working with factors. Factors, square roots, cube roots. N must be a multiple of m, or m must be a multiple of n. There's no requirement for that. They do not need to be multiples of each other. In fact, one could be 7, the other could be 35, and it would be neither a square nor a cube, despite the fact that they are multiples. Now, the greatest common factor of n and m must be a multiple of 6. In other words, they must both be divisible by 6. Has to be a multiple because they could have a greatest common factor of 12. That'll still work. If it's a square root, it's divisible by 2. If it's a perfect cube, it's divisible by 3. So it has to be divisible by both 2 and 3. It has to be divisible by 6. The same must be true of the least common multiple. So statements 3 and 4 are definitely true. And there's no requirements about which is greater than the other. So of these 6 statements, only statements 3 and 4 are true. You may actually enter these in any order. So just to demonstrate that, we could do 43. So that was working with factors. This one's, which of these numbers is rational? We're back to algebra number 2, irrational numbers. So the cube root of negative 16. Negative 16 does not have any prime factors with exponents that are multiples of 3. That is a negative 2 exponent 4. So this is not rational. The square root of 48 is not rational. That's 3 times 16. The 16 comes out as a 4, but that simplifies to 4 root 3. Square root of 8.1 is tempting because 81 is a perfect square, but that decimal messes it up. If we had 0.81, the square root of that would be 0.9. That's rational. But 8.1 does not work. The square root of 4 over 169, that's 2 over 13. That one works. Number 11, writing 42 and 5 over 4 as a radical. So we'd have to have our 4 come out as the index. Only one does that. So yes, this again, advanced exponents. The 5 stays inside, the 4 comes out as the index, not as a multiplier. Now, on a calculator, sometimes not all values can be shown. To which sets of numbers does this belong? We have to be careful, because while this does start off with the digits of pi, we do not have the ... Therefore, this is a terminating decimal. Okay, so that makes it rational, and only rational. It is not natural, it is not an integer, it is not a whole. If we had the ... then it would be irrational because there's no pattern. Without the ... it's rational. Now this one. Which expression cannot be evaluated when a is a natural number? Well, that would be the one that takes the even root of the negative number. Again, as far as this course is concerned, those do not exist. All right, now we're into our representing data, relations, and functions 1. We want to match the situations to the graph. Here we have something that's moving up and down. So this is not the speed of a car that starts at 5 meters per second and steadily accelerates. That would be option or question 16, where we're starting at 5 and steadily accelerating. B, the distribution of shoe sizes in a classroom. That would have, say, I don't know, maybe 5 at the smallest, up to, well, if the teachers are included and I'm there, we'd be up to 14. But we'd have a couple half sizes up to 11. And that doesn't fit any of these. So it doesn't look like that one's there. There are more options than there are graphs. The temperature of an oven in degrees Fahrenheit. Well, that would be steady, perhaps. We would need more information about that. The height of a falling boulder. That's starting high and accelerating downwards. We don't seem to see this. The total price for purchasing a given number of movie tickets at $12 each. Well, this would be discrete data. 1 ticket is 12. 2 tickets is 24. 3 is 36. 4 is 48. 5 is 60. And we can't have half a ticket or 3/4 of a ticket. So that was option E. And that's the graph for number 17. F, the height of a basket of a Ferris wheel that has a 20-meter diameter. That's our first graph. We go from 0 to 20, comes down and goes back up, comes down, goes back up. The height changes most quickly when you're about halfway down, and it's almost completely vertical. G is the cost of renting skis for a flat rate of $25 plus $10 for each hour or portion thereof, which means for that first hour you're paying $35, then $45, then $55, then $65. So this will have a shape of what we call a step function. It's named that because it actually looks like steps on a staircase. We take a step up. And then finally, the height of an elevator that moves between floors of a tall building. That would be something that looks like 15. It'll stay at a floor for a while, go down to another floor, stay there for a while, go to another floor, stay there for a while, so on. So, our last one, back to algebra number 2, which is an irrational number. First one looks like pi, but no ... so that's rational, it's terminating. Square root of 169 is 13. The cube root of 3 is irrational. 5/6 can be written as a fraction. That is the definition of an irrational number. Okay, I'm just checking the answer key here. It appears we have a mismatch with the answer key according to them. So question multiple choice 12. Okay. Could be because this is a calculator representation, so they are treating that as irrational with pi. On paper, it should be the ... but I guess if they're talking specifically on a calculator, calculators don't put ... We don't see a repeating pattern, so that one would be irrational. I also have to take a look at how our 4 written response are being scored. They're supposed to be 1 mark each, but it looks like right now, some are out of 1 and some are out of 5. So what should have been 5 marks right now has 8 extra. It's up to 13. As I mark them, that should be corrected. So if we reload, the note that some marks may change has gone away. And yes, this is now 100%. So by the time you do this, AN4 will be out of the 5 marks it's intended to be out of. And the one question that had the duplicate answer will be corrected. So that wraps up the solutions video for our November 18th assessment.